So so far in Trig, we have done coterminal angles, we've done general coterminal angles. So we add 360 a whole bunch of times, or we subtract 360, or we add 2 pi or subtract 2 pi if it's in radians. We have done reference angles. Reference angles are the bow tie angles, which are the angles between the terminal line and the x-axis. We've drawn out the whole unit circle already. We've done do points exist on the unit circle? If they do, can you solve for the x and y using x squared plus y squared equals 1? Right? We've done that. So what I need you to have is that separate sheet of paper, because you're going to write on that. You're going to keep it with your formula sheet, because that's going to be where we're going to add stuff on that you need to memorize for a common unit test. And you need to unit circle out. Those are going to be your besties. You're literally going to need your formula sheet and your unit circle out now till the end of time. And also you're going to trade it verbally. They're going to be your BFFs. Your formula sheet and your unit circle. And this separate sheet of paper. So, we were taught sine theta equals opposite over hypotenuse. You don't need to write this part. I'll tell you when you need to write something. You don't need to write this for just paying attention. Just bring this off back. So we were taught sine theta equals opposite over hypotenuse. Cos theta, you don't need to write this, equals adjacent over hypotenuse. And we were taught tan theta COA is opposite over adjacent. And we were taught this because we were given triangles back in the day, and the triangle could be flipped and turned and twisted, and we could use any different angle, and so adjacent and opposite always moves, right? So if you were looking at a certain angle, adjacent was always what's beside it, opposite was always what's across from it, and hypotenuse was always one across from the 90. Hypotenuse was the only one that stayed, so the opposite and the adjacent moved, right? Now we're going to look at triangles embedded on a unit circle. Okay? So on a unit circle, we're on a circle on the Cartesian plane anyway. So what we're going to have is radius and x's and y's. Because on a Cartesian plane, you have x's and you have y's, and then you have that lovely terminal arm, which is just the radius going around. If it's on a unit circle, it's a 1. If it's not on a unit circle, it could be any radius. It could be 2, 7, whatever. Okay? So we are going to use x's and y's and r's from now on. I'm just going to give you a little show on here. You're not going to write this down. I'll tell you. So on here, whenever we have opposites, because we're going to be doing unit circle angles, let's say it's like this. Your opposite of the angle, because it's the central angle always, your opposite is always your y. Your adjacent is always your x. And your hypotenuse is always your radius. Because we're literally only ever allowing you to have the central angle. Right? You can never use this angle up here. So always when rotating in the center. So of these, don't do this either, I'm just showing you. Opposite is always y, hypotenuse is r. Adjacent is x, hypotenuse is r. And opposite is y, adjacent is x. So we need to memorize these. So you can either memorize it, this is something you can write if you want. You can write opposite equals y, adjacent equals x, and hypotenuse equals r. You can write that. But most often what people use is the ridiculously stupid acronyms I'm going to teach you in a few seconds. Okay? So we could use SOHCAHTOA, and wherever we have opposites, we put y's. Wherever we have adjacents, we put x's. Wherever we have hypotenuse, we put r's. Or we can memorize these lovely formulas. So, sine theta equals y over r. And how I memorize it is sine your, I know sine was not spelled like that, your resume. I'm going to think you sign resumes, but today you're signing a resume. And for the rest of the time, you will sign your resume. Sine y over r. That's the best one out of all the acronyms, just so you know. So if you're like, that's stupid, it gets worse. Okay. So then we have cos theta is adjacent over hypotenuse, or x over r. So in the past, lots of years ago, people came up with this acronym. Cook extra rice. Extra is not spelled right. That's okay. Who doesn't need rice, right? Extra rice is even better than just normal rice. Like, oh, I'm not plugged in. Well, that would have been a really quiet one for Jacob. Mike. Okay, sign your resume. Cook extra rice. This is my favorite. For Corona, it works the best. Tan your Xbox. Because when you tan, you get vitamin D, and vitamin D is supposedly the forefront of the fight against Corona. So, if you tan your Xbox, it will get vitamin D. It will not be Corona. See? Thinking ahead. Who needs an Xbox with Corona? No one. That's what I think. So we're going to tan it, put some vitamin D, and our Xbox will be just top notch. Perfect in the winter conditions of the Xbox. Okay, these are the 3 primary trig ratios. You've known these your whole life. Well, you haven't. You've known these since grade 10, which is basically your whole life, because we keep bringing grade 10 back. Like it just never, people bring sexy back, we bring grade 10 back all the time. Okay, cool. So, this is our grade 10. Where's our grade 12 element? It's not just memorizing the ridiculous acronyms. Our grade 10 element is this part. Our grade 12 element is knowing that there's actually 3 secondary trig ratios. So we learned SOHCAHTOA. You've trusted your teacher along the way. You've trusted your teacher with degrees. Now I want to ready and stir in your life a little. Now we're going to add 3 secondary trig ratios. Can you go to your formula sheet? This is where we show you, so you never ever think it's the wrong one that goes with the wrong thing. So if you look at the top left of your formula sheet, you're going to see a formula that's equal to 1 over sine, or the reciprocal of sine. What letters are beside it? What letters beside 1 over sine? Top right. I think I said top left. CSC. So what we actually learned on that formula sheet is it says CSC. And do you see how I have betas in here? So here, I should point these out because you guys don't bring them to the occasion. If you don't have a theta in there, or a variable of some sort, that is not a trig ratio, and has some letters written on the page. So we need to have this theta in here every single time. Why do you drop them off? You can't. You must have them. So we know that secant, this is cosecant, sorry. I'll write it out so you can see what the word is. Super fun. Cosecant theta is 1 over sine, right? That's what it says. So we know that cosecant goes with 1 over sine. 1 over sine, or 1 over any fraction, is just a fraction flip. So for example, let me show you this. So if I did 1 over sine, and sine being y over r, okay? We're just paying attention. So if I did 1 over y over r, that would be the same as 1 divided by y over r, because I always write fractions both sideways, which is the same as 1 times r over y, which equals r over y. So when you actually do 1 over sine, it's just the reciprocal of sine. So if sine is y over r, cosecant theta is just r over y. It's just regular. So the secondary trig ratios are just besties with the first, with the primary trig ratio, with the reciprocal of. That's all it is. So if I have sine memorized as your resume, then I have cosecant memorized because it's just a flip. R over y. And what I get is some people think that like secant is with sine. It's on your formula sheet. It literally says cosecant is 1 over sine, so I know it's sine flip. Okay? So go to your formula sheet. Please don't give me the wrong one with the wrong trig ratio, because your formula sheet tells you which one goes with it. Okay? My next secondary trig ratio is secant theta. And on the formula sheet, what does it say beside it? 1 over cos. So secant is just cos, the reciprocal of cos. So secant is r over x. So it's not crazy. Right? It's just you memorize the first three primary trig ratios, you know the final sheet pull off the other ones and flip them. And then with tan goes cotangent. Cotangent. So they follow the tan. And that's called cotangent. I'm just writing it out so you actually know what the heck I'm saying. So cotan theta equals, if it's tan your x box, this is x box your. So those are the ones you want to write on that sheet. The 6, sine theta equals y over r, cos theta equals x over r, tan theta equals y over x, cosecant equals r over y, secant theta equals r over x, cotan theta equals x over y. Okay? So this is the sheet you want to keep with your formula sheet. Now we're going to go to a completely separate, different sheet. And we're going to work on questions and homework at the same time. It's crazy. We're going to like multitask today. We are going to multitask. Because we need to just practice and 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 practice until we can't screw up. Okay? So, close to your heart right now is going to be your sheet you just wrote out, so you have all your trig ratios beside you. And your unit circle, because that's where pulling crap comes. Okay? And I'm going to write the question in the textbook, so we're both multitasking together. So we're on page 201 of the textbook. You don't need it in front of you. I'm just telling you. And we're going to work on number 1. Number 1 says, what is the exact value of each trig ratio? So, I told you guys that when it says on the unit circle, that screams, use the formula x squared plus y squared equals 1, right? The polynomials, I said, if it says is a factor, that screams remainder 0, right? If in solving in polynomials, it said exact values, that screams probably going to have to use a quadratic formula, right? When I solve and I say exact values. Exact values in trig usually screams, I must use my unit circle. Because on the outside of your unit circle are a whole bunch of exact values. That root 3 over 2, that root 2 over 2, a half, 1, negative 1, 0, right? Those are all exact values. So when it says exact values in trig, that often means I'm going to need my unit circle. Because on the outside of my unit circle are answers. Now remember, looking at my unit circle, this is all remembering, because we talked about the unit circle last week. On the unit circle, my coordinates are cos theta, sine theta, Calgary Stampede, remember? My Calgary Stampede. So we're doing a little remembering of what the heck we can pull off our unit circle. Why is our unit circle helpful? So if I said to you cos of 30 degrees, you could type it in your calculator. We're going to try that too. So if I go cos of 30 degrees, we're not doing any questions yet. We're just remembering how to use our calculator. We're remembering how to use our unit circle. So if I go cos of 30, that means I'm going to push the button cos. What do I do immediately before I press that button cos? Make sure it's in degrees. You slap your hand and you say, I can't press that button until I'm in the correct mode, right? Because radians and degrees are both fair game at this point. There's no like leaving in degrees and life will be perfect. That is not true. Okay? Why are we putting it in degrees? Because I had cos of 30 degrees. Okay? So make sure your calculator is in degree mode and go cos 30. And what do we get? 3/2. Because we get what decimal? We get 0.8660, which is a lovely decimal. Is that an exact value? No, in our heads we may have it memorized and know it's root 3 over 2, because 0.8660 is root 3 over 2, 0.707 would be 2 over 2, 0.5 is a half, right? So we may have it memorized, so we know it's root 3 over 2, but from our calculator directly, does it give us that answer? No, it gives us a non-exact value, it gives us a non-repeating, non-terminating decimal. So, what we can do is we can go to our unit circle. We go to 30 degrees on our unit circle. So that's what we're going to do. We're going to go 30 degrees on our unit circle. And all of the x values on our unit circle are the cos values. All of the y values are the sine values, right? So I actually have every trig ratio for cos and every trig ratio for sine on that unit circle, right? So if I say cos of 30, I go to 30 degrees and I look at the x, because that's cos 30, right? What is it? It's root 3 over 2, is it not? On our unit circle, the x value. So that's our exact value, right? Can you type into a calculator memorize 0.8660 and put root 3 over 2? Sure. But that's where we're getting it from, it's from the unit circle. Okay? What if I ask for sine of 120? 120 degrees in this degree circle. You go to 120, and you're going to give me which one? X or Y? Y. What's Y at 120? Okay, what if I ask for cos of 11 pi over 6? Could I type it in my calculator? Yeah, but what do I need to be in? Radian mode? Like, put in radian mode and go cos of 11 pi over 6 straight up. So we're going to cos 11 pi over 6 in our calculators. What do we get? What do we get again? 0.8660. So is it positive or negative? It was positive. It's in quadrant 4 and cos positive. So it's root 3 over 2. Or we could go, hey, go to 11 pi over 6 on the unit circle, and I'm going to take the x value, which is root 3 over 2, right? And unit circle helps me out. Yes? Okay. But you didn't realize that the unit circle also has secant and cosecant on it. Did you know that? Secant is cos flipped. Cosecant is sine flipped. They don't go with each other. So the CSC goes with sine, CNS. The SEC goes with cos. So cos goes with secant, and sine goes with cosecant. The C's don't go together, and the S's don't go together. Remember that? If not, your formula sheet tells you which ones go together, right? So, if I want, instead of cos of 11 pi over 6, say I asked for secant of 11 pi over 6. Secant of 11 pi over 6 is on your unit circle. I go to 11 pi over 6. I go to cos because it's special. Flip it. So if cos is root 3 over 2, secant is what? 2 over root 3. And if we thought we got around grade 10, grade 10, so far we have. We're bringing back grade 11. In grade 11, we were taught how to rationalize the denominator. Because we're not allowed to have a radical in our denominator. So what we did was when it was a monomial of root 3, we can just multiply by root 3. Because, going back to grade 10, and grade 11 next, if I gave you this, just paying attention, say I gave you 2 root 3 times ramping this, I'm just showing you, 3 root 3. When we multiply radicals, we were taught to multiply coefficients times coefficients and radicands times radicands, right? And root 3 times root 3 is actually root 9. What's root 9? 3. So it's 6 times 3, which is 18. And in grade 10, you'll write 6 times root 3 every time. Root 9 is 3, not root 3, right? Square root 9 is 3. So root goes away. So the reason why we multiply anything with the same radicand by itself is because the square root will go away. Square root of 4 times square root of 4 is square root of 16, which is 4. Square root of 1,000 times square root of 1,000 equals 1,000. Okay? So you multiply two radicals together that are the exact same enough to make the radical dropping off. Right? So I want to rationalize my denominator. Secant, I flip it, and then I have to rationalize it. So multiply by root 3 and root 3. And I'm going to get 2 root 3 over 3. And that's my answer. Okay? Does that make sense? If I want to check it, is there a secant button on the calculator? No such thing. The formula sheet has to help you out. Because the only buttons you have on your calculator are sine, cos, and tan. Do you agree? So if I want to type in secant of 11 pi over 6, I'm going to go to my formula sheet and I'm going to be like, where the heck is there something that can help me out here? Because I don't have a secant button. On your formula sheet, it tells you that secant theta equals 1 over cos. We agree? So I can, instead of typing this in, I can type in 1 over cos 11 pi over 6. That's the only way I can type it in. So if I ever need to type in secant, I'm going to have to type it in that way. You can formula off your formula sheet. So type it into your calculator, making sure you're in radian mode. Okay, so I'm going to go mode. Make sure I'm in radian. Okay, I am. Second click can get me out of there. And then I'm going to go 1 divided by cos, what did I say? 11 pi over 6? Is that 11 pi divided by 6? And I get that. Or because that bothers me because it doesn't look like what I was actually typing in. When I have a fancy calculator, I can go alpha y equals enter and make it actually look like it. 1 divided by, and this makes me happier. Not sure why, but it's just. And I could have made this a fraction as well. I always say that, right? Now, I have an answer 2 root 3 divided by 3. Matches. Right on right. I can check these. Right?
What is, if you press second and then press the sine, cos, or tan button, what does that do? Is that
To get an angle.
Oh,
Not only to solve for theta, which we're going to do tomorrow. No.
okay.
Okay? So literally, off your unit circle, you can quickly pull cos and sine, the x and y, and you can pull secant and cosecant, because they're just the flips of the x and y, right? We're going to try to fuse them up. Then we have to talk about tans and cotangents, which you can pull from there as well. So 1a is sine of 45. I want the exact value of sine 45. Do I need a calculator at all? Tell me why I'm having my textbook like I was or something. Sine of 45. So we're going to go to 45, and we're going to take off the what? The x to the y. The y, because it's Calgary Stampede, right? So the y. Wouldn't matter in this case because it's the exact same answer, but it's the point of it all. So the y at 45 is root 2 over 2. We're done. That's how easy this question is. If you want to know what crazy math I see when I get this question, it's craziness. I'm just going to get an answer off the unit circle. Just put it and walk off. Right? Sometimes you get half a page of work. I don't know what you're doing. Okay? So it's literally just asking you for the trig ratio. This is the trig ratio. This is y over r of that triangle. Is that it? Stop having it there. Cos, 3 pi over 4. So I'm going to 3 pi over 4 and quadrant 2. And just the x or the y. Quadrant stampede. And x in that quadrant is negative, so it's a negative answer. You get negative root 2 over 2? Only It stayed that easy for life, right? You don't seem to have it coming up. Cosecant, 210 degrees. Don't forget the degree symbol or it's a radian. Cosecant starts with a C. So it doesn't go with cos, it goes with sine. Say we totally forget. We can go to our formula sheet which says it's 1 over sine, right? So I'm going to go to 210 and I need sine, which is Calgary stampede, which is sine y, and I'm going to do what to it? Flip it. Because cosecant is the flip of sine. Secant is the flip of cos, right? So at 210, what do I get for sine? For 210, I get negative what? Negative 1/2. So if I want to on the side here and go sine 210 equals negative 1/2, which is lovely. If I flip that, what do I get? Negative 2 over 1. Do I need the 1? No, every number is over 1, right? Like if I have like number 6, I can put it over 1 if I want. So I don't have to keep it. So it's negative 2. Done. All right, for rationalize any denominator. Because half is, when you get half or 1 or stuff like that, you just 50%. You don't rationalize. D. Ooh, tan. Tan is 3 pi over 2. So I talked about the unit circle always has cos and sine, right? Calgary stampede, you know that. Unit circle has its besties, secant and cosecant, we know that. It's just a flip version, right? Tan is not directly on there. You can't like flip and twist something to get tan. But if you look on your formula sheet, is there a formula for tan with sines and coses? Because I know that unit circle has sines and coses on it. What's the formula for sine and cos with tan? Yeah, sine theta over cos theta, right? So tan theta equals sine theta over cos theta. Well, my theta happens to be 3 pi over 2, so I'm going to write it as sine 3 pi over 2. So I have an extra step when it's coses or when it's tans and cotans. And cos 3 pi over 2. What's sine of 3 pi over 2? So sine Calgary stampede. I need the y. So what's the y at 3 pi over 2, sorry? Negative 1. Then I need to put it over cos of 3 pi over 2. What's cos of 3 pi over 2? 0. And what's the devil's magic in math? Dividing by 0. You're not allowed to do it. Your math ticket. Like, this is so illegal. If you put it in your calculator, it will say error. That's how we know how bad it is. Our calculator doesn't even like it. Throw it out. So when we see this, when it's 1 divided by 0 or negative 1 divided by 0 or a number divided by 0, we're going to say undefined. We're going to say undefined. I think calculators literally are like way more hardcore than a cell phone.
Yeah.
You can drop it off the Empire State Building. I'm sure it would just bounce. Some batteries would fall out of it. Put some batteries back in. Just roll. Okay. Does that make sense? So we have sine and cos in the unit circle. We're going to use them. If it's cotan, it's just cos divided by sine. So you literally just copy off the formula sheet. Formula sheet, best friend. So you can memorize it. It's great. Okay. I am so doing that in order. That's so funny. That was like A and C and E. I'm doing it in my own order. Okay. Tan of 30. This is not at all how the textbook rolls. I did not follow it very well. Tan of 30. Tan is sine over cos. This was harder than the previous one. Sine of 30 degrees over cos of 30 degrees. Sine of 30 degrees is what? Show you what you should not do. What's sine of 30 degrees? A half? What's cos of 30 degrees? Root 3 over 2. You should never do this. If you're stacking fractions at any point in time in 30-1, say, that looks stupid, don't do it. Okay? Because how do you flip and multiply when you have them stacked? The answer is you don't. You don't flip and multiply it. You stare at it longingly, sadly, and then you just sadly move on or cry or something. And that would be bad. Or worse than that, you type in your calculator. Typing in your calculator is worse than crying. You had all these beautiful exact values, and then they just disappear. It's sad. So when we do trig proofs, the same thing's going to happen. I need to embed into your body that when you see a fraction divided by a fraction, you say, wow, that looks dumb. I'm going to write it out sideways. That's what you need to do. Fraction over fraction, I'm going to write it out sideways. That's what needs to pop in your head, just like x-intercept y equals 0. See fractions stacked, write them out sideways. So what does this little slash in the middle mean? Division symbol. So I'm going to go 1/2 divided by root 3 over 2. And then hopefully, when you write them side by side, that screams flip and multiply. Okay? So we're going to get 1/2 times 2 over root 3. Then when you multiply cross top, cross bottom, so you get 2 over 2 root 3. The 2's cancel. You get 1 over root 3, and then you think, well, I'm done. And then Mrs. Lepp wrecks your life, and she says you have to rationalize your denominator. So more steps. So when you see a cotan and a tan, just be a little sad, because they take a little more time. Just a little sad, not a lot of sad. So I'm going to get root 3 over 3. Tan at 45. Any of the 45-degree reference angles get you 1 or -1. Those are the ones you want. They just cancel everything out. Tan at 30 gets you root 3 over 3. Tan at 60 gets you just root 3. You'll see common things happen. Okay? But you don't memorize that. You just use your formulas. All right. What random thing now? Cotan. 7 pi over 6. Can I pull cotan stuff in unit circle? Nope. Can I use its friends, cos and sine, to get its answer? Yeah. Go to your formula sheet and look for cos theta equals. And you need to find the one that equals something with coses and sines. Everyone needs to find it because I need you to practice your formula sheet. I know where it is. Cotan is 1 over tan, but what's a better thing to use? Because we're going off right off the unit circle. Cos over sine. So when we're using the unit circle, this one is a good one too, but we want to use these top ones because tan, I can just take sine over cos directly off my unit circle. Cotan, I can take cos and sine directly off my unit circle, right? So I'm going to rewrite this as cos 7 pi over 6, which is the x at 7 pi over 6, divided by sine 7 pi over 6, which is the y. So type that. What's x at 7 pi over 6? Oh. Pardon? Negative root 3 over 2. And then sine is negative 1/2. I've stacked fractions, so that should scream unstack the fractions. Negative root 3 over 2 divided by negative 1/2 equals negative root 3 over 2 times negative 2 over 1, or negative 1 over 2, 2 over negative 1 doesn't really matter. Negative times a negative actually makes it a positive, so I get 2 root 3 over 2, the 2's cancel, and I get root 3. We're going to put in some info. First off, we don't have to rationalize there's no denominator, right? It's in it. Info that you were taught last year was cast. C-A-S-T, right? 7 pi over 6 falls in this bad boy. One, doesn't it? What's positive in there? No. I'm taking my, in this quadrant, tan is positive and its best friend cotan, right? Because if cotan is just a flip of tan, if tan is positive, and I just flip it, cotan is still going to be positive, right? So the only answer here that's to be positive is a cotan or tan. So when I look at cotan there, it's positive, I should be happy. I have the right sign. Okay? How could I check it? Well, remember I can't type in cotan, so I have to go to my formula sheet. And cotan of 7 pi over 6, I could type in as cos of this sine of this, right? That would work. Just type that in. So cos of 7 pi over 6, the flat is here if you have changed it right here. So cos of 7 pi over 6 over sine of 7 pi over 6. You should be able to check our answer. Now we get it. And then go root 3. They should match. Do they match? Yeah, so we know we did okay. All right? Now we don't want to just bank on our calculators, because if we go to university and go to calculus and then they tell us we can't use our calculators, we can use our unit circle, you're in big trouble if you don't know how to use your unit circle. I had a cousin who that happened to. He was like, I don't even know what the unit circle is. And I said, I think you're in trouble. So, a conversation. All right. So, G. You're going to try on your own. My random G, because it's not real. Have I not done? Ooh, these are getting good. Secant of pi. And then a challenger. H, which is not really actually the H in the book. Secant of negative 240 degrees. What's going on? So I set you up something new over here and a little bit new over here. Secant is besties with cos, and cos is what on the unit circle? X, which is the flip of it, right? So if I go to pi, it's over here on my unit circle, which is at negative 1, 0, cos is negative 1, correct? And negative 1 is just over what number when I don't have a denominator? 1. When I flip negative 1 over 1, what do I get? Negative 1. So the answer is just negative 1. Remember, I could type that in my calculator. I could go 1 over cos of pi, right? It says it right on my formula sheet. That's how I can type it in. And that'll give me negative 1. Okay, negative 240 is not on that unit circle directly. Correct? So I can either draw negative 240 and see where I land on, or I can find its what? Coterminal, which is why we taught coterminals in the very first lesson. So how do I do coterminals? I can either add 360 for life, till I get something I want, or I can subtract 360 for life, till I get something I want, because that terminating arm will terminate on the same spot, right? So secant of 240, if I go to negative 240 and I add 360 to it, so I want to add 360 because I want to get onto the unit circle. I'm negative. What does that give me? 120 is 120 on my unit circle? Yeah. So secant of 240 is actually the same as secant. It equals secant of 120. I'm going to show that middle step. Now when 20 is on my unit circle, when 20 has an x point that goes with it, an x variable, what's the x at 120? Negative 1/2. So I know cos of 120 is negative 1/2. So what's secant at 120? Yeah. Negative 2. If I wrote negative 2 over 1, would they drop on the left? No, this won't be a multiple choice option. It'll be negative 2. So do you see all I did there was I found the coterminal? That's it. Nothing crazy. Nothing fancy. Okay. I. Cotan of negative 120, 120 degrees. J, cos of 390 degrees. K is going to be sine of 5 pi over 3. And L is going to be cosecant of 495 degrees. So negative 120 is outside. So I'm going to go negative 120 degrees plus 360 degrees. And I'm going to get 240 degrees. So cotan of negative 120 is the same as cotan of 240 degrees. Cotan, I can't pull off my unit circle, but I can pull off cos of 240 degrees divided by sine of 240 degrees. What is cos of 240? Is it a half? Negative a half? Divided by root 3 over negative root 3 over 2. So that's me negative a half times negative 2 over root 3, which equals 2 over 2 root 3. The 2's cancel. So it's 1 over root 3. And then I need to rationalize. So I'm going to get root 3 over 3. Cos of 390 is actually really easy once you figure out what component is, because it's just the x, right? So 390 is too big. So I'm going to go 390, and instead of adding 360, I'm going to subtract 360. And it gives me 30. So cos of 390 equals cos of 30. And what's x at 30? Root 3 over 2? I believe. Sine of 5 pi over 2. I go to 5 pi over 3. On a unit circle, and you give me the y. What is it? Negative root 3 over 2? Yeah? No. Positive a half? What is it? Did I just say negative root 3 over and over when I was saying negative root 3 over 2 in my head? I think so. I think that's what's happening. I'm saying no, but I'm like, that's what it is. But I wasn't saying the over 2 first. But my head was saying it. I know it's over 2. Okay, cos of 495 too big. Cosecant, sorry. 495 minus 360 equals what? 135. So cosecant of 135, we go to 135. I take my sign, and I flippy flip it. And I get 2 over root 2. And it's positive, right? Rationalize. You get 2 root 2 over 2. And the 2's cancel. Now, some people have tried to cancel the inside of this. Can I just cross that off? No. I can cross off coefficients. The only way I'm reducing a radical is taking a perfect square out of it. And because I don't want to waste time, I'm going to get you guys to do this next question on paper 12. So I'm giving you a coordinate not on the unit circle. Using the coordinate negative 3, 4, not on the unit circle. Determine the 6 primary trig ratios. Or the 6 trig ratios, not primary. And these are called trigonometric ratios. So we need the 6, which means we need cos, sine, tan, cotan, cosecant, secant, all of them. Okay? This is when I'm given a coordinate. When I'm given a coordinate, the first thing I need to do is draw the coordinate. Expect it. So it's at negative 3 and 4, so I'm going to sketch it. Now, this coordinate is on the terminal arm, which for some reason I forgot to write that. So it's on the terminal arm. Anything that's on the terminal arm starts at 0, 0, and goes to it, correct? Now, if I were to draw a triangle, do I draw bow ties or hourglasses, which are the worst thing you could ever do in your entire life? Bow ties or hourglasses, which are the worst thing you could do in your entire life? Bow ties. Hourglasses are the worst thing you could ever do in your entire life. You're never going to draw an hourglass, okay? So if you feel the need to like try and draw towards the y-axis, don't do that. That would make hourglasses, right? We're never going to do that. We're never going to draw the y-axis, never. Not once. There's no, nothing that's different. If we're going to draw, we're always going to draw towards the x. So we draw bow ties. Because if I kept going, I would get bow ties, right? Now I can measure this. This down here is the length of negative 3. This here is 4. I need to find this side. So back to grade 10. How do you find the that side? Okay, here, because this is a 90 here, this is my what? My hypotenuse. Or my c squared, if we were to use c squared equals a squared plus b squared, right? So step 1, draw the coordinate. Step 2, determine your radius. It's called a radius on here because it's, if I kept going around, that would make a circle, right? So determine your radius using x squared plus y squared equals r squared. You could technically do a squared plus b squared equals c squared, no one else your c. It's not a big deal. But we label it as an r plus your radius. So we're going to do r squared equals negative 3 squared plus 4 squared. R squared equals 9 plus 16. R squared equals 25. Take the square root. And we have to remember to put plus or minus whenever we take the square root. So R equals plus or minus 5. The catch is R is a radius. And a radius is a length of measure. And length of measures cannot be negative unless it's a vector quantity, which it is not. Okay? So our R is going to equal 5. So we know that x equals negative 3, we know y equals 4, and we know r equals 5. We have everything we need for trig ratios. Because all the trig ratios used is x, y, and r, right? So now we can write out our trig ratios. And you have them in front of your face on that separate sheet of paper that I said you need to hold close to your heart. So I'm going to go x equals negative 3 just for my own welfare, y equals 4, r equals 5. All right, so our first trig ratio is find your x box. What can you not forget? Or let's say that. Please don't forget it. Don't forget the little cowboy that hangs out beside the sign. Or you have no spot for an angle and you will lose marks. Sine theta equals sine your resume. So sine theta in this case equals 4/5. It's positive. Does that make sense? Well, let's use CAS. What's positive in the quadrant I'm sitting in? Sine and its bestie. What's its bestie? Cosecant. So if it's sine your resume, cosecant is resume your. So it's just going to be 5/4. Then we have cos. Cos theta is cook extra rice. So cos theta in this case equals -3/5. It's negative. Should it be negative? Negative? Should it be negative if we're in this quadrant? Yep. Only if it should be positive. Sine and its bestie. Cos's bestie is secant. So if it's cook extra rice, this is rice extra. And secant theta equals -5/3. Or I could write it as 5/-3. Or I could write it as -5/3. All three of those are the exact same thing. You just have to take a negative and put it somewhere. So they can, why do I say that? Because you can write any of those three, but so can they on multiple choice. And I don't want you to be thrown off because they put the negative on the bottom or on the top. Okay? I wouldn't put all three, I'd pick one. You know what I mean. So tan theta, tan your X box, we don't want it to lose its vitamin D. So y/r, or y/x, sorry, it's negative as well. Should it be negative? Yes, because the only thing that quadrant should be positive is sine and its bestie. And then cotan theta, instead of your X box your. The cotan theta is -3/4. Does that make sense? So for your homework, there's going to be two that you're going to do. I'm going to give them to you. The coordinates are, the one coordinate is, I can't remember that. It's in here. It works out nice, like the other one. 5 and 12. So you're going to show this for your homework. I want all 6 trig ratios, right? At that coordinate. And then the other one I want you to do is more advanced. I can't remember what it is. -2 and -6. -2 and -6, sorry, I lied. And then your only other question is from your textbook. Page 202, number 9. And you have like 15 minutes, so there's a good chance you could demolish this.